Hello everyone, in this video we're going to be talking about momentum and impulse. Linear momentum is defined as P equals mass times the velocity, and the units are kilograms times mass. The momentum of an object is directly related to its inertia. The higher the momentum, the harder to stop the object. And the total momentum is just a combination of all the momentums inside a closed system. And there's impulse, which is defined as the force times the change in time. And the units of it is newtons times seconds. Impulse is a force that is being applied to an object. It can be a kick or a shove. Now is a good time to learn about impulse and momentum theorem. Impulse is equal to change in momentum. So here we can see that the final mass times final velocity minus the initial velocity and mass is equal to the impulse. And the units are the same too. So we can say that newtons over seconds and kilograms times meters over seconds can both use to denote impulse and momentum. Now, let's solve this question. Determine the momentum of the rubber ball bouncing off the wall. So this rubber ball is 1 kilograms and it's coming at the wall with a velocity of 30 meters over seconds. Now, we need to find the momentum of the ball. So let's do it. So first of all, the formula for momentum is P equals m times v. This ball is coming at the negative x direction. So negative x, and this is the positive x side. And it's going to bounce off to the positive x direction. So we know that the velocities are going to be in different directions. This information is going to help us. So let's calculate the momentum. So P is equal to m final and v final. So this is change in momentum, m initial and velocity initial, and these are both vector quantities. So the initial mass is 1 kilograms and the initial velocity is 30 meters over seconds minus. So the final mass is the same because there is no change in mass. But if you take a look at the velocity, it's going in a different direction. So it's going to be negative because it's a vector quantity, and it's going to be negative 30. And this is equal to change in momentum. So let's find the numbers. Negative 30 minus negative 30, and we get negative 60 kilograms meters over seconds as the answer. Or you can denote it by newtons times seconds. Now is a good time to talk about force time graphs because they give us the impulse. So the area under the force time graphs gives us the impulse. Graphs realistically look like the first graph here, which is denoted by A. But for simplicity reasons, we usually use them like this. So in a shape of a triangle, so that it's much easier to find the impulse by using this formula, which is the formula used to calculate the area of a triangle. So height times the base is going to give us the impulse. Now let's solve this question. So 0.2 kilogram soccer ball is kicked. What's the final velocity? So you know that impulse is equal to the change in momentum. The change in momentum is going to be the final momentum minus the initial momentum. And in order to find the impulse, we simply take the area under the force times time graph, and we use the area of a triangle to find it. So let's find it. The area of a triangle is going to be half of the base times the height. So this is equal to the impulse. So half of the base, which is 0.1 here, and 100 as the force. We simplify these and get 5 newtons seconds as the impulse. And this is equal to the change in momentum, so we can plug it in here. Now, let's further solve this question. So we have impulse, which is equal to 5, and m final and v final minus m initial and v initial. So 5 is equal to, the mass is 0.2 kilograms, which we know from the information in the question. So 0.2 kilograms. We don't know the final velocity. It's actually what we were looking for, so we're going to use it as a variable here. Minus the mass is 0.2, and the initial velocity has to be 0, assuming that the ball was stationary at the beginning. So we're just going to say 0. This is going to cancel out this side, so we're left with this side, and 5 divided by 0.2, because we divide both sides with 0.2 in order to find the final velocity, and the final velocity is equal to 25 kilograms meters over seconds. Now we're going to talk about conservation of momentum. the momentum in a closed system is going to stay the same. So the total initial momentum is going to be equal to the total final momentum. Let's look at this question in order to further understand this fact. A 3 kilogram rifle that is initially at rest contains a bullet with a mass of 0.03 kilograms. The bullet is fired from the rifle at a speed of 300 meters per second towards the east. What is the recoil velocity of the rifle? Okay, so we know that the total momentum is going to be equal to 0 because it was 0 at the beginning. So let's further solve this question. The momentum of the bullet plus the momentum of the rifle, which is going to give us the recoil, is going to equal to 0. The sum is going to equal to 0 because that's what we had at the beginning. Now let's find the momentums. So here, the momentum of the bullet is going to equal to the mass times the velocity of the bullet. And the mass of the bullet is 0.03 kilograms. The velocity of it is 300 meters per second. Plus, the rifle is 3 kilograms, so 3. And we don't know the velocity of it, and that is actually the value that we're looking for. And this whole thing is gonna be equal to 0 because at the beginning, the momentum was 0. I'm gonna use a calculator to find the numbers. So the momentum of the bullet is 9 plus 3v, and this is a rifle. And this has to be equal to 0. I'm gonna subtract 9 from both sides, and we get negative 9 equal to 2 VR. And I'm gonna divide both sides by 3. So we know that the velocity of the rifle is equal to negative 3 kilograms meters per second. Now let's talk about energy in collisions. There are two main types of collisions, which are elastic collisions and inelastic collisions. Elastic collisions are relatively simple because in an elastic collision, the kinetic energy is conserved and the momentum is of course conserved. So we simply use the formula that we have used all the time. In elastic collisions though, there are two ways around. The first one is perfectly inelastic collisions that we're going to talk about in a bit, and inelastic ordinary collisions. In elastic ordinary collisions, momentum is going to stay the same, but the kinetic energy is going to be less because we're going to lose some kinetic energy to create some heat that is going to happen because of the vibrations of the particles that is being touched to each other. So in the situation of an elastic collision, you can think of this as, these two parts. So the surface and the ball is not really touching each other, but the ball is being repelled by a magnetic force per se. But here it's actually being hit, so it's creating a heat because of the collision, and then the kinetic energy is being less because we get to subtract the kinetic energy from the initial energy of the ball, which can be seen in this equation here. In perfectly inelastic collisions, the same goes, but in perfectly inelastic collisions, the elements fuse each other. So as we see here, they come together and they become one mass. And the momentum is conserved, but the kinetic energy is, of course, lost. So in order to find the momentum of the system, the initial velocities, and so in order to find the final momentum of the system, we simply add the two masses together. So at the beginning, they were the same as before, but they become together as one mass. So we calculate them in that way. And there's also kinetic energy loss, which is calculated in this way, but this time not similar to inelastic ordinary collisions. The masses are coming together just like here. So let's answer this question. Car of mass 700 kilogram and moving at a speed of 30 meters per second collides with a stationary truck of mass 1400 kilograms, and the two vehicles lock together on impact. What is the combined velocity of the car and truck after the collision? So we can simply see that there is a perfectly inelastic collision going on. And let's plug in the numbers for that. So the initial velocities are going to be the same, but after the collision, the masses are going to come together and they're going to make one whole mass. And we need to find the final velocity here. So let's plug in the numbers. The initial mass of the car is 700 kilograms, and the velocity of it is 30 meters per second. And the truck is stationary, so we know that this is equal to 0. And if the velocity is equal to 0, there's no momentum, so we can just get rid of that. And this is equal to the total mass times the final velocity. So let's find the total mass. The truck is 1,400 kilograms, so 700 for the car and 1,400 for the truck, and final velocity. So this side is equal to 21,000, and this is going to be equal to 2,100 times the final velocity. Let's divide both sides by 2,100, and these cancel out, and the final velocity is 10 kilograms meters per second. Thanks for watching this video. I hope you enjoyed it.